In this video, we will go over Boolean Algebra in the American Computer Science League Junior Division Contest 3 as of 2023. So before we start, it's really important that you know these identities on the left side of the screen. So the absorption laws, distributive laws, De Morgan's laws, double negation, and these Boolean algebra identities. Some of these overlap, but you really need to know how to apply these to problems before you solve the contest, because in the contest you don't have access to these identities. Instead of memorizing all of these, what I advise is that you solve a lot of practice problems and get used to these identities instead, because ultimately it's about how you can use these identities in problems instead of having to memorize these identities. So without further ado, we will get into question number 4. Question number 4, that's from our problem set from our computer science competition team. So anyways, if we get into this problem, we have, sorry, that was weird, A not B plus not C plus not AB. If we look at the choices here, what we notice is that A, B, and C are separated in the last simplification of this identity. So we want to move towards separating all of these variables, A, B, and C. The first thing I notice is that A and B are stuck together here, so we're going to use identity 6 or identity 7 to separate not A, B. So what we have is A not B plus not C, that's exactly the same, plus not A plus not B. That is because of, where is it, identity number 7, not A times B is equal to not A plus not B. Okay, so then the next thing we can do here is distribute. That's the only thing I can see here, so that's what I'm going to do. A not B plus A not C plus not A plus not B, because that's going to give me a lot of overlapping variables, and if we have overlapping variables, we can use absorption laws. So the first thing I notice here is I have not A plus A not B plus A not C plus not B. The reason why I rearranged this such that not A is going first is because I want to use the second absorption law. X plus not xy is x plus y. If I say that x is not A and y is not B, we can see the exact same pattern in this part of the identity, not A plus A not B. That is because A is just not A. So then we can replace this part. Let me get rid of this first. We can replace this part. We can replace this part and say not A plus not B. And then we have A not C plus not B. Obviously, we have a not B plus not B, and we have A plus A equals A. So not B plus not B equals not B. So we can just erase one not B from here. Not A plus A not C. Again, we see the same pattern, not A plus not A times C. If we, again, assume X to be not A and Y this time to be not C, we can see the same pattern. So if we, in this case, we can just say not A plus not C plus not B. If we rearrange this, we have not A plus not B plus not C. So the answer for this problem is B. We will move on to the next problem. The next problem's slightly more interesting because it asks you how many ordered pairs make the following expression true. If there are 3 variables, it's going to ask you for an ordered triple. If there are 4, which happens very rarely, it's going to ask you for an ordered quadruple. Whenever you see ordered pairs, don't be scared by it. I've seen that a lot of members in my team were scared by it, but all you need to do is simplify, and especially for problems with 2 or 3 variables, which is mostly the case, you can just brute force every single possibility. And chances are, if the problem is easy enough, the number of variables might even decrease. So that's another good thing. So first, without thinking a lot, we just have to simplify the equation. This is pretty interesting. Not parentheses, not a plus b times not ab. It's really important that we get the parentheses correct because that might change the answers. Anyways, again, we see inside a not, we see multiplication. So if we use the De Morgan's law of multiplication, turning it into addition, we can say a not a plus b, parentheses obviously, not there, but plus not ab. We know that a not is just cancels. Okay, so we have that. And a plus b plus ab, we see a similar pattern here because a plus ab is the same pattern as x plus xy, the first identity in this Google Docs. So to avoid confusion, we will rearrange this part. A plus ab plus b. A plus ab is just a plus b. That's if we distribute a plus ab, but we know that so a times a is just a. So we have a plus ab, and we know that a plus ab is the same format as x plus xy, so that's just absorption law. A plus ab is a. So then the final simplification for this identity is a. But don't be tricked here, because some people might say we want to make it true, just a is 1, but that is not the case, because if we leave b out, we're just saying that b can either be 0 or 1, and it will not affect the result because b is going to be cancelled out anyways. So we always have to keep in mind that b can be either 0 or 1, but a always has to be 1. So a always has to be 1, and within that possibility there's b equals 0 and b equals 1. So then if we have this, a equals 1 and b equals 0, we can have 1 comma 0, and if we have a equals 1 and b equals 1, we have 1 comma 1. So these are the two ordered pairs that make the following expression true, and therefore the answer is C. And with that, all I have to say is the problems are not going to get much difficult from this difficulty, the difficulty I just solved. If you want more challenging problems, you might want to look at intermediate and senior problems, or some of the final contest problems. But this difficulty is enough for you to practice for contest 3. Please know these identities for contest 3, and if you need more information, you can always visit the ACSL official website, and they have study materials for Boolean algebra. They have this whole Wikipedia page on Boolean algebra that comes out in the ACSL. They have like a step-by-step solution for a sample problem, videos, and even Boolean algebra calculators. Obviously you can't use this on the contest, but if you need a step-by-step solution for any problem, you can use this calculator, I think. So with that, I'm gonna end this video here. Hope we all do well in the third contest.